Hi, I'm Carter. Today I'll be discussing the mean value theorem. The mean value theorem states that for any function f of x that is continuous and differentiable from on the interval a to b, there exists at least one point c on the interval a to b that has a slope equal to the slope from a to b. So for my first example problem, I will be discussing sine of x from the point a at x equals 0 to b at x equals pi. So the formula for the mean value theorem is f of b minus f of a over b minus a equals f prime of c. So f of b equals 0, f of a equals 0, and b minus a is pi minus 0, and this equals 0. So you set f prime of c equal to 0. Next, you take the derivative of the original function, which is cosine of x, and you set it equal to 0. And it has to be on the interval from a to b, which is 0 to pi. So cosine of pi over 2 equals 0 on that interval. So that is the answer. It's pi over 2 is the value on this graph that has a slope equal to the slope from a to b. Next example is x squared from the point a at x equals 1 to the point b at x equals 2. F of b equals, or f of b minus f of a over b minus a equals f prime of c. F of b equals 4, f of a equals 1, and then b minus a is 2 minus 1, so you get a solution of 4, or of 3. And then you set that equal to f prime of c. Take the derivative of the original function, which is 2x, and you get an x value of 2/3, or of 3/2. Which once again is on the interval from 1 to 2. And that is your answer for the second problem. Now, I will give you an example to try at home, which is going to be 2x squared plus 5x plus 1. Two x squared minus 5x plus 1. And then find the mean value from the interval a equals, a is x equals 0, and b is x equals 2.
Hello, I'm Garrett Broemer, and I'll be explaining the extreme value theorem. The definition of the extreme value theorem is if a function f is continuous and in the closed interval a to b, then f must contain a maximum and a minimum. Closed interval being no piecewise functions, no holes, and no asymptotes, vertical or horizontal. Going on to the first example, f of x gives you the function of the graph that looks like so. From the interval a to b, the maximum is at point C and the minimum is at point D, giving you a maximum coordinate at C of 3, C3, and a minimum coordinate at D of 1. On to the next graph. Minimum and maximum can also be the endpoints of the graph. On this point, the minimum is at B of 1, and the maximum is at A of 4. Going on to the third example, on this graph, it may seem that there is no minimum, but the minimum will be at A of 1, and the maximum at C of 7. Now I'll give 2 takeaway problems. First takeaway problem is you're given a function f of x, and the function looks as so. On the closed interval a to b, you are given c, d, e, and f. What is the letter value of the max, and what is the letter value of the min? The second, a little bit more difficult. Function f of x is equal to ln of x over x. On the interval 1 to e squared, what is the absolute minimum of x, and what is f of x equal to? In other words, what is the coordinates of the minimum?